Hello everyone, so in this video I'm going to demonstrate a very simple analysis with latent profile analysis in R with a package called tidyLPA. Okay, so a question that I have received from many people is what are differences between the latent class analysis and latent profile analysis. So they are actually different at conceptual level rather than computational one. So it really depends on the topic of your research and the areas that you're researching. You need to read more into the theoretical difference between them, but it's beyond the scope of this video. But just for a quick differentiation between the two, I have listed out some very basic one. For example, the criteria here we have type of data. Latent class analysis will be performed with binary or dichotomous data, which is 0 or 1, yes or no. So there are only two types of answer. But for latent profile analysis, you can use this analysis with continuous data like score, age, and so on. For the goals, the main goal of latent class analysis, or in other words, the step, what you are concerned most about is how many classes are there in classes that can represent your population, okay, the best. But for latent profile analysis, it is more complex. There are two major steps. The first, you need to identify and select which models that you want to run. So there are actually 6 models. There are actually 6 models in latent profile analysis, and you need to choose one of them based on the fit indices like the BIC or the AIC value. And then in step 2, you want to examine how many classes are best represented in population. Well, basically this one is similar to the latent class analysis. Alright, so for the 6 models in LPA, this is just you need to know the variance and covariance. So this is just basic statistical knowledge, and I'm not going to talk much about it. But model 1, there are 2 criteria: variance and covariance. Variance, equal variance, which means you assume that each variable is similar in terms of the error, which is V1 and V2 similar. A covariance is the connection between the two. If you choose model 1, that means you assume 0 covariance. In other words, there is no relationship between variable 1 and variable 2. For the similar explanation can be applied to explain other model 2, model 3, 4, 5, 6. But keep in mind that for R, you can only run with 1, 2, 3, and 6. You cannot run model 4 and 5. You need to use M+ to run this model. Also, like for example, model 6, if you choose model 6, that means you assume that there are variant within each variable. They are not similar in terms of variance, and they are not fixed to 0, or they're not fixed to equal. That means the covariance are different among the variable. Okay. Next, for this video, I'm going to demonstrate an example. So I have 3 observed variables: the second language listening score, intrinsic motivation, extrinsic motivation. Now I want to cluster my participant based on these 3 observed variables, based on their listening scores, based on their intrinsic motivation, and based on their extrinsic motivation. Is that the people with higher intrinsic learning motivation who have higher score, and so on. Okay, we're gonna use the package called tidyLPA. So let's start. First, what you need to do is you need to install the package. Okay. But you also need to install another package that only go with tidyLPA, that is dplyr. Alright, now we need to load both of them. Okay, now I already load both of them. You can click run, or you can just type Control Enter to execute your command. Alright, now we need to read our data. Okay, our data. Here's a point. There are many methods to read your data. You can use read CSV, or you can use read Excel, and so on. But in this case, I'm going to use read tidyLPA. I strongly advise that you save your data in CSV or text file or text, this one, and don't import it directly like from Excel, because in my appearance the Excel file doesn't work very well in terms of presenting giving it data to R. So you should from text or from CSV. Okay, let's run. Alright, now I will locate my data. I believe I have successfully loaded my data, but just to check it. Okay, we only work with scores, intrinsic, extrinsic. We're not talking about test anxiety and critical thinking in this study. Okay, right. The next thing we're gonna do is to start running our latent profile analysis. Yesterday, I'm gonna type M3 as the name of my model, and then data, which is the name of my data. Select. We can use select to choose the columns of data that we like to use for our latent profile analysis. You have to use this symbol because this symbol belongs to the package dplyr. It helps to pass the result from the previous argument or method to the next. You must use this for this analysis. After we select 3 columns that we're gonna use in this analysis. Then you're gonna use single imputation. The package doesn't allow for missing data. So if you have missing data, you have to use single imputation. You don't have to enter anything in this because the package dplyr will have you passing the data into it. But you do need to use this symbol. Alright, next, it is optional. You can, if you want to scale your data, like to turn it into 0 is the average, and then 1 or -1 at the score. So that's called scale. It's a form of transform your variables. In this case, I'm going to use it because it's easier to to standardize all of my variables, easier to view and to plot. Okay, and then we're gonna estimate profile. For estimate profile, I will estimate 1, 2, 3. 1, 2, 3. Variances equal covariance 0. Okay, so you will, if you remember, I already talked about variances and covariances. So if you look at the table again, you will see that I specify my variance as equal and my covariance as 0. So that means I have selected the model 1 as my model to run. In the similar way, you can specify model 2 by changing the name of equal to varying and a covariant to 0. It really depends on the conceptual level and a theoretical perspective that is suitable for your study, that you choose which one. But again, model 1 is the most popular one. Alright, I noticed I have didn't put symbol right here. Okay, so let's run our. I believe we have successfully run the latent profile analysis. Now we want to view the result.